So what I want to speak about today is a very specific analytics challenge that we had in the organization. I'll first to start talking, I'll give you a very brief company overview. We are a major supplier to the railroads. Many of the products that you saw in the last presentation, Progress Rail provides to our rail customers. Talk about an innovative partnership that we established to deal with the challenge, the analytics challenge, excuse me. And then give you an insight into the solution that we came up with, what we call Progress Rail Uptime. It drove change in our organization, and we'll talk about some specific customer benefits as a result of the application, and then we'll finish with lessons learned. So Progress Rail is a Caterpillar company. Progress Rail was purchased by Caterpillar in 2006, and then in 2010, Progress Rail purchased EMD, which is an iconic locomotive brand in the industry called Electromotive Diesel, which was previously a General Motors Corporation. We divide our products and services into two main areas, which are rolling stock and infrastructure. Under the rolling stock side, we have new locomotives, both freight and transit, and locomotive repair and maintenance, and then freight car, both new, and we're the largest provider of freight car parts and freight car services and repair in North America. On the infrastructure side, we have a track business and a signal business. The track business, again, a lot of the things that you saw, switches, crossovers, maintenance away of equipment to maintain the track, vegetation control. And then on the signaling side of the business, the signal systems, the infrastructure that support the signal systems and the bungalows that you saw. So our corporate philosophy is cradle to grave. We produce new products, then we build, service those products over their life, repower locomotives and repair rail cars. But then at the end of the life, we have a recycling business where we reclaim the ferrous metals and the aluminum as part of the business. So cradle to grave business cycle, and our strategic focus is bringing value to our customers. So our challenge was we had a locomotive monitoring platform that had been in-house, developed by our in-house engineering people. It was over 18 years old. It was a very old computer system, but predominantly based on locomotive faults. And we hadn't made a significant investment in that system called IntelliTrain for over 10 years. And so when I joined the company in 2013, I really had a choice. It was, do I bring in-house developers and data scientists, or do I look at externally developing, refreshing the application? And after pretty extensive research, we found Uptake in our neighborhood in Chicago, where we actually build locomotives, and we decided that the best way to move forward was with a partnership to kind of revamp. So what I think is really different and unique about this partnership, to my knowledge, we are the first OEM that has partnered with an analytics provider, a true analytics and software development company that was outside of the rail industry. And what it's allowed us to do is we each focus on our core competencies, which is very important. We have long-term relationship with customers. We've been building locomotives for close to 100 years. We have the knowledge of the industry, the knowledge of the locomotive and the products. Uptake is a pure analytics provider. They were predominantly in the business-to-consumer space prior to our relationship and prior to 2014 when we started the relationship. You may be familiar with their Groupon application, which is a pretty famous business-to-consumer application. But we together brought them into the industrial space, and it has been a very, we call it a collaborative disruption because it's different. The tendency is for an OEM to develop everything in-house. And as you can imagine, the people that design locomotives are really good at designing locomotives and locomotive control systems and the software to control them. They're not good application engineers, data scientists, and software application developers. So it's been a great and very, very productive partnership. So we say the OEM knowledge plus an analytics partner has delivered measurable value for our customers. So the solution is what we call Progress Rail Uptime in our industry. Uptime of all of your rail assets are important, whether it's people, whether it's the track, whether it's the cars and locomotives. It's critical that those assets are available and ready for service. When the interesting thing about the application was we were able to start green sheet, meaning we didn't dictate to Uptake what technology to use, what applications. We weren't forced to try to force fit a legacy system into the application. They start with a clean sheet. And although we started with locomotives because that was the application that needed the most focus initially, and as you saw in their presentation, it's one of the second largest creators of train delay, right? So it's an important asset on the rail. So we envision it to be a solution for the rail ecosystem, meaning we have wayside devices, we do car monitoring, bearing monitoring, wheel monitoring, locomotive monitoring. The application was designed to take large sets of data and provide analytics. And the real magic is in predictive analytics, meaning it's one thing a rail customer would say with a fault and failure sort of methodology, don't tell me a locomotive is on fire when I can look out the window and see it. I need to know before it catches fire where I can do something about it and minimize the disruption to the network. So what it forced us to do is we had to stand up our own rail cloud, a secure rail cloud, to a place to handle and deal with all this data. We had to rethink our communication strategy on board these assets, right? Change the frequency, reduce the cost of the frequency of getting data off a locomotive and into our rail cloud. And then the Uptime Analytics, which is the platform that does the analytics. Again, the secret sauce is being able to predict weeks and months in advance before a locomotive failure is going to occur, move the model from condition-based maintenance move it from time-based maintenance to condition-based maintenance. And what that means is, right now, everything on a locomotive is overhauled or changed based on megawatt hours, right? But some of these components, like a traction motor, maybe they go twice the life, right? But because on average they fail at a certain megawatt hours, you change them out. So you don't have, it's a huge disruption if a traction motor fails on a locomotive. And so if you can really get good with your prediction, you run them till near failure and then change them out without ever causing a disruption to the rail network. That's the real difference between prescriptive and predictive analytics. So we talk about what kind of entitlement do we have on the locomotive. And as you imagine, when we first started this journey, we looked at the major systems like the engine, the alternators, the traction motors, the cooling system. But over time, the customer doesn't care why a locomotive fails. They just care that it fails and it fails on a network and causes significant disruption. So as we build more models and build more algorithms across to cover the locomotive, it's critical that you get as much entitlement as possible. So right now we have models that cover 90% of the locomotive failures that occur, and they do it automatically, which is critical, which allows our people in our monitoring center to work on the outliers, right? You're always going to have, if you have a fuel pump that's from a supplier that there's an infancy failure on it, you don't have a big enough data set to create a model to be able to predict that failure. So it comes down to people that are experts that are looking at fuel pressure and can make that analysis manually, right, or with the data. But the greater the entitlement is that you grow in the application, the more automation you have and the better predictive capability that you have. So this slide reflects results that we've actually seen on several of a conglomeration of Class 1 customers that we've done pilots on. It reflects about a 6-month duration of the pilot. And so what we've been able to say is that we've produced $175,000 per locomotive per year worth of annual savings, which is very significant. We break down the application into 3 strategic areas: in the shop, in the yard, and on the track. And so examples of in the shop, if you know exactly what's wrong with the locomotive before it ever gets to the shop, you can minimize the work scope, meaning this is what you need to focus on, this is what's broken, you can make sure the part is there and available at the shop before the locomotive ever arrives. So you're significantly reducing the work scope. Instead of a locomotive coming in and you have to troubleshoot the electrical system, the mechanical system, cooling system, you go right to the point of failure and to the root cause. In that area, that represents the $100,000 worth of savings. In the yard, it's all about when a yard master is making up a train, he's got cars and he's got locomotives that he's going to apply to the train. He needs to know the health status of that unit before he applies it to a train, because it's very costly. You apply a sick locomotive to a high priority train, it either fails before it gets out of the yard or it fails in line of route, and you've caused a significant disruption. So we provide a health score on the locomotive that gives the operations group a real-time view of how healthy is this locomotive, and should I apply it to this high priority train? Should I apply it to a train at all, right? And then the last thing, while it's on its mission, we've been able to show a 1 road fly reduction in failure. That means we've prevented 1 locomotive failure per year on line of road, which is pretty significant with the technology. And then this is a summary of our international, so predominantly it would be a mining customer. Their train value is very high because it's an iron ore train or it's a coal train, and they know that if that train has a failure, that's generally tonnage that you're never going to get to the port and get to the ship. So you lose that on an annual basis. So we monitored roughly, we've been monitoring about 1,000 locomotives in the mining field trials. We've been able to prevent 169 road failures over that locomotive fleet, and 150 of those road failures would have been mainline delays, meaning very, very significant, over a 3-hour delay where you have to go out and send a crew, send another locomotive to replace that sick locomotive, that failed locomotive. In the same study, we were able to prevent 3 catastrophic engine failures and a 34% increase in mean time between failures. That's a very significant number of reduction in mean time between failures. We've, in one shop only, we were able to save about 1,500 man-hours over a 3-month period. Again, that's by knowing what's wrong with the locomotive before it gets there, being very specific on the root cause and what you need to do to repair it. We combine oil sample data from the engine along with our models on the engines, and with using the oil sample data because you're looking for impurities in the oil, you're looking for ferrous metals, you're looking for water in the oil. We've been able to add 30 days of predicted time with those oil samples to engine failures. And again, we've about 400,000 of additional savings in idle time using, it's called AESS, automatic engine start-stop. But when those systems aren't operating properly, they don't shut down the locomotive when the conditions are favorable for a locomotive shutdown. And then again, one shop, 3 months, about 35,000 gallons worth of fuel savings. So very meaningful, significant savings as a result of the analytics platform. Again, we started with locomotives. We'll deploy it broader than that. So what are the lessons learned? You know, my strong opinion after 3 years of working together is either an analytics provider or an OEM alone really won't be successful. From the equipment manufacturer, we know how the locomotive is supposed to function. We know all the insights into it. There are times when, you know, high oil pressure and high temperatures don't mean anything. It means the locomotive's in a tunnel. So you really have to know the context. Outside temperature, you need to know whether it's raining, whether it's snowing. When you combine all that information together and then how a locomotive is supposed to operate, that's what we've been able to impart to Uptake's data scientists to be able to predict very accurately when these failures are going to occur. Second is it's patience is required. It is a challenging process. These locomotive, you know, on a year, again, talk about terabytes worth of data. There's a ton of data, and you have to really understand what's important and what's not important. What's noise in the system? What are the critical functions that you need to monitor and model? And then finally, you know, we replaced an internal system. Probably each of you have been through that. Change management is critical. Nobody likes it when you take away their system and create a new system. You really have to get buy-in early, and you have to be able to show them that it's a benefit to, one, it's easy to say, hey, we've improved the lives of our customers, but we also have to improve the lives of the employees using the system of our locomotive monitoring center. It's tough, but you just have to plan for it. And then finally, in the rail industry, if you have a solution, you're very likely going to pilot it. If If I go to CSX and say, hey, we've had these benefits at Norfolk Southern, they're going to say, I don't care. My network is significantly different. My operations are significantly different. You need to model my fleet in my operations. You just have to be prepared to make the commitment. You're going to do it. Each railroad, whether it's passenger, mining, or freight, are significantly different in general. And then what I've seen on this journey, which has been, I've been in sort of the data analytics side of the rail business for about 10 years, is there's a lot of data out there. Everybody has data. Still today, there's a lot of manual intensive processes in organizing and scrubbing and in analyzing that data. The more that you can build models and algorithms and use data science to process and automatically get insights into that data, the better you move, the faster you move from just being able to say there's a problem with the locomotive to predicting there's a problem ahead of time and being able to do something about it. Thank you so much.